being streamed all the way from India. What could possibly go wrong? So next up is my former colleague Matt. So I might inflict the full Chat GPT introduction of him upon you. Ladies and gentlemen, it's our privilege to introduce our next speaker, Matt Travis, representing Address Cloud. Matt is an accomplished geospatial data engineer. That's not how I remember it. With a passion for exploring and harnessing the full potential of geospatial technology and data. As a dedicated member of the OSGeo UK community, and also the treasurer picking up the bill today, so I better take that last comment back. Matt's expertise extends beyond his role at Address Cloud. He spends his days on a relentless quest for new technologies, relentless, Matt, that can be harnessed to enhance geospatial solutions. Equally important, he is a skilled communicator, better than me clearly, who excels helping others navigate the intricate landscape of geospatial technology and data. I'm only halfway through.
No, it's okay. Thanks, Dan. I appreciate that. I'll use it for my next CV. So.
Okay, yeah, there you go, mate.
Who said ChatGPT doesn't lie? Hi, everyone. So I think you kind of know who I am now. I've met quite a few people here before anyway, and through various guises. So I'll just quickly introduce myself. I've been working with geodata for close to 20 years. Local authorities in the UK, Plymouth City Council, then Dartmoor National Park, and then moved to Aston about 2019, just before Phosphagy in Edinburgh, which is really great. Got through the pandemic with them, some tough times, and then I moved to Address Cloud recently, about a year and a half ago, where I've been working as data analyst stroke engineer. So my job mainly consists of moving data from one place to another. That's what I tell people anyway. I'm also treasurer for OSGeo UK, and I've helped organise Phosphagy events in 2019 and the 2020 online one, and last year. I haven't had much to do with this year, thankfully, but I appreciate all the efforts that everyone's put in to get these events up and running. It's been something we've wanted to do for a long time, and last year was the first time, and yeah, going from strength to strength, hopefully. So thanks, everyone. Okay, so a little bit about Address Cloud. Address Cloud was funded in 2015, and it's often said it's been born at Phosphagy because many of the main engineering team either met at Phosphagy events. Mark and Thomas, I think in Seoul back in 2015. Anyway, I'm not sure exactly. And it's a geocoding and location intelligence service, and we're working predominantly within the insurance sector. So originally it started as geocoding, providing addresses and a pinpoint location via an API or other methods to the insurance industry. But also more recently we've moved into local intelligence. So that's like perils, risks, things like that. Fire risk, well, basically all these things here. So flood, fire, subsidence, and crime. Flood tends to be the biggest one in the UK, as you may have guessed. So yeah, we tend to concentrate on that quite a lot within the UK. So insurers need to avoid having too much risk in a single location, but what is that location? So that's what we try and help them determine, and we'll build a new platform which is being launched next week called Risk, and that will help us be able to show the accumulation of data within like building blocks, countries, other zones, and give them a real idea. So instead of just having a spreadsheet, they can have a map, they can have an application, they can share that. It's the power of spatial. We're all aware of that. Okay, so yeah, quick, brief talk about what I'm going to do. Talk about today, and I'm going to cover cloud native geospatial. So hopefully most people know what cloud native data is. It's essentially just data that is in the cloud and it just lives there. You can grab it, you grab what you need when you need it. It's generally an S3 bucket, it's Azure, etc. And yeah, it's in various data formats, which I'm going to discuss. I'm also going to give an example of a data store that I've been accessing, and just run through a couple of open source tools. Okay, so what are the benefits of using cloud native data? So it's obviously it's structured to be efficiently retrieved, like I said. So people are aware of geotiffs, I guess. Yep, most people use GeoTIFFs. This talk is all about vector, by the way. There's no raster in this, because that's what we do use GeoTIFF, but for this particular project I've been working on, we've been more interested in bringing down vector data, so buildings data from OSM, etc. Yeah, so some of the benefits, it's faster for users, so you can quickly go and get the data you need, stream that part, same as GeoTIFF, stream the part you need and download it. No need to download and store copies of data or even DVDs, if you can remember back in the old days getting data from the OS. So overall, it just saves users time and money, which is, as someone pointed out earlier, a good way to engage with the business and say, like, this is a good thing to be doing. Okay, so I grabbed this slide from Chris Holmes, who is a massive proponent of cloud data, probably like one of the key people worldwide who's pushing it and has developed GeoTIFF. He's worked in GeoServer, but I grabbed this slide from him, and I know shape is off there, and it really shouldn't be. I think that's just something Chris was kind of joking about, but I'm just going to look at these. The two mains I'm going to look at are Parquet and GeoParquet and flat GeoBuff. So flat GeoBuff. It's a binary format, so instead of like your text, like GeoJSON, it's a binary format. So it's a lot faster to load and to stream. And again, similar to GeoTIFF, it works well with large volumes of static data. So because it's static, because it's just there, it's not editable. You don't even need an index. You can just grab what you need. I know I keep going back to this. You can stream what you need, and instead of downloading the whole thing. And it's well supported by GDAL. I think it's been GDAL since 3 at least. QGIS, and more recently it's been added to Tippecanoe. Tippecanoe is a tool for creating vector tiles, which I'll talk about later. And okay, so it can be directly streamed and used by Leaflet. I've got a link there. When the slides are published, you'll be able to go and click on that. I don't want to do it now because I don't want to risk not getting back into my slides. So unfortunately, I'm just going to skip over that. Okay, so next format I'm going to talk about is Parquet. So as you can see, like Parquet is represented here like Parquet flooring. So anyone who's aware of Parquet flooring from the 70s, I think it's a bit popular again now. The reason they've taken that is because it's commular data, so it's not stored in rows; it's stored as columns. So instead of like having an ID, a geom, and everything stored in rows, all the IDs in one column, everything else, all the attributes stored in columns. So you can then chunk up the data, and then you can quickly retrieve what you need and stream that part of it. So it's a lot quicker to filter on. If data is stored in the cloud, you can partition it. So partition by year, and more within geospatial, partitioning by location, or say country code. That's something that I've seen more recently, and that's what it's really useful for. It's currently in release candidate, but version 1, I'm told, is very imminent. So that would be good, because it's an OGC standard, or it's going to be adopted by the OGC. It's very new. It doesn't work in an awful lot of tools yet. It works in QGIS if you run it QGIS with Conda and you install libraries, and it runs in GDAL the same way. But yeah, it's very new, so just keep an eye out for it. It's used by Overture Maps Foundation, and yeah, I'll go into that in a minute. So who's involved in GeoParquet? So a lot of the big data companies like Carto, Databricks, BigQuery, and the smaller libraries like GeoPandas, things like that. And GDAL can read it. They're all moving towards GeoParquet as like the standard, the cloud native standard for vector. And so I think it's only a matter of time before it kind of becomes like the de facto not for for large spatial data, global data, say, but GeoPackage will probably still be the big one for smaller data. Another format that I'm just going to briefly touch on because it's really useful and it's cloud native as well. The PM tiles. Again, I'll put a link in there so you can grab it. That is PM tiles is like MB tiles, if anyone's ever come across that, where you can. But with MB tiles is like an exchange format, I'd class it, for vector tiles. So whereas normally vector tiles, same as raster tiles, are in like lots of different directories at different zoom levels. Vector tiles is very much the same thing, but that when you're trying to transfer that from one server to another, it takes so much time because of you've got to read the input output for each file just takes far too long. So what you can do is package everything up into MB tiles file and move that across. PM tiles was developed by Brandon Liu, I believe his name is, and he runs Protomaps. Saw a talk from him last year in Fossage in Florence, and I was just really intrigued to see what it was all about. And PM tiles lets you host the tiles in a S3 bucket and stream directly to MapLibra and other. I haven't tried it on anything else. I've not really tried it a great deal, but I'm just amazed that you can do that. So you can basically stream a global data set straight to MapLibra from the cloud. So it's definitely worth checking out, and you'll probably see a lot more of it. How am I doing for time? Cool, loads, yeah. Okay, so data store. Overture Maps Foundation. How many people have heard of Overture? Most people, by the looks of it. Most people. Okay, that's good. So it's OMF, as I'm calling it there. It's started by a lot of the big tech companies, so AWS, Microsoft, Meta, and TomTom. There's additional members who, for some reason, I've left off there. Precisely, they're a big American outfit. I think they bought MapInfo some while back. SafeGraph, they've got a lot of POI data. They've joined. Esri have joined. SparkGeo have joined. I'm reliably informed. Brilliant. Yeah, I mean, a lot of people are joining this foundation and trying to be part of it because, you know, they can feed back information. I'm guessing there's going to be working groups. So yeah, if you're interested in global vector data, definitely worth keeping an eye on that and maybe joining as a member. Something that we're thinking of doing potentially. It's based on, I say it's based on OSM data, but I think the key component is OSM data. It's available freely to, I think, the same license conditions as OSM data. I'm pretty sure it's an open database license. But yeah, it's also bringing in other data sources. So it's got the Microsoft machine learning buildings, stuff from Esri, a lot of point of interest data as well. It's separated into themes. So it's got admin, buildings, places, and transportation. So we're mostly interested in admin and buildings. It's still in its infancy and still a bit raw. The admin data is a bit strange. Some of it, it's in line string, but you can get the countries and the regions, and there's only 2 admin levels at the moment, and they don't have all the attributes that you might need, like names. So it's good. It's good to view, but it needs a lot of work. The buildings are great, and the places, which is points of interest, is really good. The data was hosted within S3 buckets as parquets, and I don't know why I left that bit off, but yeah, it's essentially just it's a massive folder of parquet files or separate S3 buckets, not folders, sorry, which you can stream using many different tools, which I'll mention one of them later, or you can download. It's 200 gig in total from memory. I think the buildings is about 111. So the buildings is by far the biggest component. And the data, so previously what you would have to do would grab like the whole planet file. So if you ever try to get OSM data and just get a bit of what you need before, it's quite painful. You have to get the whole planet file and then use a tool like Osmosis or OSM to PGSQL, which, yeah, if you've ever tried doing it, you'll know what I'm talking about. So this is a lot easier once I think more tools are available to read Parquet directly, and the data is also provided in GeoParquet, which I think it's only a matter of time before all this happens. Okay, skip to the next slide. Another data store that I want to quickly tell you about is something called Source Co-op, or Co-op. I think that is, not to be confused with Co-op stores. Collection of data sets which is maintained by Chris Holmes. It includes data from Google, Google Open Buildings, and Overture, which we've just talked about, and also has some data from the OS, which Chris is, I think he's just basically taken like OS buildings and added that to it. Not just, but that's what he's done. The OS, I'm informed, are looking potentially at releasing some data as Parquet. So watch that space. But yeah, nothing concrete there. It's available there in the link, so you can grab it once the talk's published. Okay, so I'm now jumping on to, how am I doing for time? Dan, plenty? Cool, yeah. Cool, okay. Okay, so Tippy Canoe. This is one of the tools I'm going to talk about. It doesn't read directly data from the cloud, so it's not a cloud native tool per se, but it's one of those tools that's great for working with big data, and I've used it a lot, and I just wanted to include it. So you can build vector tiles, as it says there, from large or small collections of GeoJSON, flat, GeoBuff, or even CSV. It's developed by Erica Fisher at Mapbox, but it's now maintained by Felt. It's very important, if you ever want to use Tippy Canoe, that you go to the Felt one, because that's on the main version now, and it's not maintained in Mapbox. Inputs, as it says there, you can use flat GeoBuff, CSV, GeoJSON, and the outputs are MB tiles and recently PM tiles. So you can get cloud spatial data, convert it to PM tiles using Tippy Canoe, and then you can load that into an S3 bucket and then serve it from there. Right, so this is the one that I'm most excited about. Has many people heard of DuckDB? Quite a few hands. Yeah, many people used it. Yeah, cool. Okay, go and use it. It's amazing. I just get really excited about some software from time to time. This is one of those things. It's just so easy to use. It's easy to download, to install. The documentation is great. There's a good community. Yeah. So anyway, it's an in-memory database engine. So it's effectively using your memory that you have in a machine. So there are limitations in that respect, but that's similar to other data processing tools I can think of. It's been called SQLite on steroids. Under the hood, it's using Arrow. It's great for working with big data, especially data that's stored as Parquet. And it can scan remote data. There is a few issues scanning some remote sources because of the region. If you're in a different region to where the data is, then you're going to notice some latency there. There's really good Python library for it. There's R bindings as well. There's other bindings. You can use it with WebAssembly. So you can use it in web pages or websites. But the Python library is great. It's available on Colab. So if you want to go and have a play, if you're into Colab, you can just install it direct from there. It's also got some really good extensions. The spatial one is well supported and it's moving at quite a fast pace. Just going to talk about that briefly. And there's also a Postgres one for really reading Postgres, scanning databases from there, and an Excel one, bizarrely, but for people into that kind of thing. So I'm just going to skip over this slide because I kind of covered it anyway, but it's basically saying when to use DuckDB and when to not, and it's just from their website. Basically, it's very good if you're doing stuff locally or on a machine and on a one particular data set. It's not great if you're trying to do lots of transactions. It's not a replacement for Postgres, PostGIS, or SQL Server. That's not what it's about. It's great for analytics. DuckDB Spatial. I'll put some QR codes in here, so if you want to have a look at it, you can take a photo. spatial extension allows you to convert to other spatial formats. It uses GDAL under the hood. It conforms to the simple features for SQL specification. So that's all your like stuff that you normally get, like GM from text, which you really do need with Parquet, intersection, intersects, basic, all your operators, all your spatial functions that you get in Postgres. Not all, I must add, but not everything that's in Postgres, but a lot more. Not a lot more, sorry, but a lot still. Okay, so DuckDB, this is just a quick, I wanted to show you guys, but I'm just worried about time. Well, I've got a bit of time, but I'm worried about it not working on the machine. So I've just copied this into here just to show you what you can do. So you open DuckDB, you install the spatial extension, you load the extension, and then what you can do is, so what it's doing here is, I'll do it line by line. It's taking the ID and the geom, but you're having to create a geom from well-known binary there. And that creates a geometry column. And you can use your standard where statements. It's standard SQL basically. So standard SQL. And yeah, here I'm basically doing where the geometry is a polygon or multi-polygon, and then I'm pushing out to flat GeoBuff. So you can do that with any format. You can do it with GeoJSON, GeoPackage. I've seen people on some of the GitHub issues using it for GPX, which is interesting. But yeah, it's just really, really, it's a powerful tool and flexible and really interoperable. So yeah, got a lot of love for it. That's my last slide. How much time we got? Oh, that's okay. I'm happy not to do a live demo. I would go on to their website and just give it a go. It's really, really good to download. So that's my talk, I think. So I rattled through quite quickly. Appreciate that. Thanks.
Hi, sorry, battery's gone on this mic. Yeah, any questions for Matt? Yep, here. I'm gonna have to run up and down.
Thanks. What's that? Oh, I see. Oh, okay, yeah. Thanks very much. It's really interesting. So I've only just really started dabbling with Parquet and GeoParquet, but I've mainly just been using like the arrow bindings in R and stuff. What's the advantage of DuckDB like compared to just going through GDAL or arrow? Is it the SQL, like having the access to the SQL stuff? Yeah.
Yeah, for me personally, having access to the SQL, but also the extensions. So having that ability. If you're using Python and I'll take it using Python, you're using arrow. Personally, I don't use R myself, but yeah, Python, it's absolutely fine. When I first started using DuckDB, I was primarily in Python using it, but I've just found it easier. And another thing I didn't mention, you can set up DuckDB in dbeaver. So if you use dbeaver, there's a connection for DuckDB, so you can just run in there, which is, if you're used to using that environment, is a really nice thing to do. Yeah, so for me, it just works better. But I'd use it in Python, and I'd use it in Python as part of a workflow for sure. I wouldn't use the command line. The command line stuff's more like, for me, on just experimenting, and yeah, like just getting data at the moment. Yeah.
Thanks, Matt.
Thanks. Just wondering about the usage at Address Cloud of it. So have you migrated to a DuckDB Parquet solution, or will you? And what is it currently? What's the sort of stack currently?
So we're like we pride ourselves as being like cloud first, serverless. The stack at the moment, our data warehouse is Postgres. We have a staging database with lots of data in it. I think because we're moving to look at more global solutions, things like Parquet, obviously at that scale, at global scale, Parquet size, speed you can access, that's why we're moving to it. So this is a very new thing. And basically what I've just been talking about is what I've been doing for the last 6 months or so. Just kind of like a brain dump, really. But yeah, we're still using the normal tools we would, but we're using Docker containers within Batch, AWS Batch. We're an AWS host, I should have said. But yeah, I'll talk more if you want afterwards. Thanks.
Brilliant. Thank you, Matt. Great talk. Really good. Just finding the next presentation, which is from Thomas, I think. So let me introduce Thomas. Thomas is a geospatial data scientist with a profound understanding of the ever-evolving landscape of geographic data structures and spatial analysis. So this is a lightning talk entitled Moving Between Traditional and Emerging Geographic Data Structures for Advanced Spatial Analysis. And while standardization has simplified the representation of geographical processes, recent advancements in computation and data storage have opened new frontiers in geospatial analysis. Are we good?
Cool. Yeah, it's just a bit slow.
Do you need your speaker notes?
Speaker notes. No, I've got them on here.
Okay,
I just need a keyboard to.
Yeah, nice. Yeah, just the arrow keys on that.
Okay, cool. All right, thank you, ChatGPT, for that introduction. Yeah, so in this talk, I'm going to talk about geographic data structures and moving between them, and why you should consider specific ones in specific use cases. So, yeah, so the outline of this talk is what is a data structure, showcase how fundamental they are for geospatial, yet they're often overlooked, how to move between them, and hopefully make you question what data structures you use going forward. So, yeah, so what is a data structure? In the most simplest sense, it's any data representation and its associated operations. What makes it geographic? So geographic ones allow you to organize and embed your spatial relationships. So proximity, nearest neighbor queries and so on. It's all about those operations. So the three fundamental data structures we have in Geo are tables, surfaces, and graphs. Tables are referred to as vector data, surfaces as raster, and graphs as networks. Okay, so a simple example. This doesn't use geographic data structures, but data structures in general. So give us directions from the engine shed to the pub using an OpenRoute service as the routing engine. So we first need to get a geocoder to get our coordinates. We need to convert it to a list because that's the data type ORS likes. Then we call the API to grab the routing. Then we get the output, which is based on the results. The distance is 200 meters. The duration will be 143 seconds. And if we decode it in not many lines of Python, we convert to multiple data structures, data types, and algorithms. And that's the output there, just in case you don't know what Google Maps is. Okay, so moving on to geographic data structures. In this example, we want to create a simple model to predict crime, a linear model in this case, using number of geographic features from different geographic structures. So we're going to grab the crime data from the API. I manually downloaded it because I can't be bothered to get the API set up last night at 11 o'clock. So we grab the data from 2023, January 23 to now, and then we'll use some smart techniques to transfer between those different geographic structures. So we use DuckDB to quickly grab the lat long coordinates from all the months subfolders within this directory. We'll grab the IMD, which we'll use as one of the features to predict crime, and plot it, just if you didn't know what the IMD looked like in Bristol. Then we need to convert it to British National Grid and make it spatial, because most operations work best in projected coordinates. We're also interested in population data, so we get the world pop raster data from that local download there, because it wouldn't let me download it on the fly. Clip it to the Bristol boundaries, and yeah, remove the no data values. So this is what it looks like, just for reference. It's kind of a bit, the color's not great, but you get the idea. So yeah, one technique we can use is to sample the points, the raster. So we'll grab the crime data points, and we'll sample from the raster, and we'll grab the population data values from there, like that. And then we're going to grab the Uber H3 polygons using the IMD LSOA boundaries. Then aggregate the crime data to the H3 polygons. That's what it looks like. And then to transfer the crime data, so the IMD data to the H3 polygons, we can use a set of techniques called aerial interpolation. And there's lots of different techniques methods you can select. But the most fundamental aspect in terms of minimizing bias and uncertainty is the choice of targets here. Generally, the smaller the grid cells you select, the higher the bias and uncertainty. So I use the most simplest method, which is aerial weighting. And yeah, so after joining all that data, we have a very simple linear model. So this is the first example. And the next example, we're interested in checking out cycle routes within the Bristol boundary. So we're going to grab the Sustrans cycle route data from the Bristol Open Data API. And after that, quickly plot it. We will clip the line strings themselves to ensure we only start within the Bristol boundary. We don't want any of the Sustran cycle network beyond the Bristol boundary, because that's what this cyclist is interested in. One user may be interested in selecting the smallest route, whilst another may be interested in the largest one. So that's a simple non-spatial query. And I don't think you can see the map, unfortunately, below. An alternative user may be interested in a more complex question, sort of, I want to complete all the routes over a course of a weekend between Saturday and Sunday. So we need to split the line strings between two, essentially partition them into two sets. So to do that, we need to transform it into a graph using MumPy, which converts into a graph readable by network X. We then use some algorithm to partition the network into two. We have a set of two dictionaries. We then need to transform those dictionaries into data frames, and then make it spatial. And then, again, because I was lazy and didn't want to manually match the points that I putted from above here to each of the line strings, I did a spatial join. I should just join to the nearest line string. So that's the output we have. So that's what the algorithm suggests. I probably wouldn't recommend this to a non-cyclist because it's quite a big route, but in this toy example, this is what the algorithm suggests. You could also use traveling salesman problem to solve this problem, but yeah, in this scenario, I just decided to use this just to showcase why choosing geographic data structures is important to conduct to answer certain questions. So yeah, so there's no right or wrong data structure within Geo. Many geospatial problems can be solved using the same different techniques, and it's ultimately up to you to decide what structures are best in certain circumstances. That's the end of my talk.
Hello? Any questions? Any questions?
Hi, Thomas. Thanks for that. Great talk. Just wondering, I noticed you used OX or OSMNX and a few other Python tools to boot. But do you use these in production, or is this kind of analysis?
Analytics, yes.
Analytics, yeah.
Yeah.
Okay, cool.
In production, yes, depending on what we're looking at. But
Yeah, okay. I might have a chat later, but yeah, it's interesting to know you see some of the tools you're using.
yeah, I mean, in production, there's other tools like Pandana, which is way faster than
Yeah.
NetworkX.
Okay,
But
yeah,
for this
okay,
demo,
cool,
it's fine.
great, thanks.
Are your slides online anywhere? I'd quite like to play around and go through the examples myself.
Oh yeah, sure. It's
Okay.
if I can exit.
Okay. All right. Okay, great.
It's all online, so yeah.
Yeah, all the slides from today. Any other questions? No? Cool. Well, thank you, Thomas, for your talk. Excellent. I think we'll press on. We're slightly ahead of schedule, which is good, I think, because we've got to switch over to the keynote. So this is the last in-person talk of the day, last but not least, and it is my delight, it says here. Not tough, you've got to listen to this. It's my delight to introduce Ilya, who has been doing all the tech stuff for today, and there's been a lot of work, in fairness to him, both. I think you've come on site about 3 times to set it all up and try it out and test it. So thanks for that, Ilya. It's been amazing. And Ilya, I don't know whether you knew this, but is on a mission to bring the world of geospatial information to a global audience of athletes. Do you know that, Ilya? Leveraging the power of data to enhance their experiences. Hailing from Bristol, he's a dynamic force in the realm of geospatial data processing in the cloud. And he's doing a lightning talk entitled A Very Brief Introduction to Argo Workflows. But this isn't your typical presentation. It's humorous and engaging. It's a humorous and engaging exploration of the limitless possibilities that arise when you dare to dream deep in the realm of data processing. And so it goes on. But Ilya, over to you.
Thank you, ChatGPT. Oh, sorry. Thank you, Sam. Jesus, we're all supposed to be nerds. Okay. Testing. So, Inception, or a very brief introduction to Argo workflows. With this talk, I'm going to pick up on a very thin thread from the last Phos4G conference here at the Engine Shed, where Ant presented on using QGIS's graphical modeler, and how in the GIS world, we're very used to thinking about data processing as linked units of work, where data processing tasks have dependencies between each other. If you think about QGIS Modeler, FME, or Model Builder in the GIS that shall not be named. In software engineering, these types of data processing structures sometimes get called directed acyclical graphs, which is basically a fancy name to say that they've got lines between each of the data processing parts. But there's been a proliferation because of AI and the rise of data science, etc., of various softwares and platforms offering the ability to orchestrate these data processing workflows and then deploy them on your compute, whether that be in the cloud or physical or whatever. So you think about things like Airflow, which developed Airbnb, NiFi, which was developed by the NSA, I believe, in America, dbt, Databricks, etc. But today I'm going to introduce Argo, which runs on Kubernetes, what you can do with it, and how we've been using it. I also love a tortured metaphor. So hopefully by the end of this, you'll understand the Inception reference, or not, who knows? It's Christopher Nolan, so. Come on. There we go. So just a quick introduction. I completely missed the fact that Dan was doing a GPT introductions. I work at FatMap. FatMap was acquired by Strava last year, as you can tell by the totally sick threads that I'm wearing. And we're slowly integrating technology between both applications. If you haven't heard of Strava, then ask one of the people around you, because apparently 1 in 7 people adults in the UK have it installed on their phones. FatMap's a little bit more niche, but since around 2014, and we were the first consumer application to mobile devices after Google Earth with this. We specialize in displaying 3D map data on devices with a focus on outdoor adventures and exploration. So this is kind of some of the stuff that we do. We build a 3D map of the world. We process our own satellite imagery. We stream in satellite imagery. We stream in topographic maps. We stream in lots of what we call reference data. So yeah, we bring lots of data together so that people going out into the mountains can make decisions, explore, find routes. You know, there's guidebook elements, etc. But I'll move on because Dan told me not to make it too much like an advert. So how do we get all of this rich data to the map? The elevation data, winter and summer satellite imagery. We also do winter satellite imagery, which is quite niche. It's one of the reasons why Maxar actually kind of allowed us to start working with them, was because we basically wanted something that not a huge amount of people want unless you're into, I don't know, snow. Vector data like roads, pistes, lifts, etc. Routes and POIs, which is more the kind of user-generated content. So obviously there's a lot of APIs that bring that data to the clients, literally hundreds at this point. And then, of course, there are a lot of data pipelines. One of the ways that we run these various data pipelines is with Argo workflows. Not to be confused with Argo CI/CD, which is for your continuous integration and development and deployment. And there's also Argo events as well, which lets you hook into event streams like Kafka. But I'm going to be talking specifically about workflows. So Argo Workflows is an open source container native workflow engine for orchestrating large data processing jobs in parallel, potentially if you want to, on Kubernetes. Its main advantage, as I maybe briefly mentioned at the start, I was supposed to, is that each unit of work in an Argo workflow is a container. So therefore, anything that you can put into a container, so literally any tool that you can run, if you can run it headlessly, etc., any code from any language, any piece of software, as long as you can put it in a container, you can have it execute some work on a piece of data or actually do anything. The container as a unit of work and the ability to then link those together and express workflows with all of the flow control that you'd have in code mean that it's flexible enough to handle an incredibly broad range of processing jobs, as much as you could dream. You can have single step kind of workflows where there's no dependencies between tasks. You can have these slightly fancier DAGs that we're actually quite used to in the geospatial world. And it's implemented as a Kubernetes custom resource definition. So that's Argo itself. So if you don't know anything about Kubernetes, don't come and talk to me after, because I'm not going to explain it to you. No, do. I love it. You can define the workflows as YAML or as Python. There are some other APIs as well. There's like, there is an API, like Argo exposes an API. So there are some, there are ways of hooking into that from other languages, but generally you can express workflows or you can write workflows as YAML, or there is a Python framework called Hera, which has like got a lot of active development on it, where you can define, your various workflow objects in Python, which is, familiar to a lot of people here. So out of the box, Argo comes with a UI, which is running on a server, which deploys within your Kubernetes cluster. And so you can manage your workflows and visualize them through that. It comes with data artifact support, so you can talk to your S3 data store or your Azure Blob storage, whatever particular flavor. You can also mount disk volumes that you've got existing within your cluster. So if you've got a whole bunch of data that's just on a disk volume in your cloud storage, then you can mount those in. You can template workflows, so you can think about that as like saving a model out in QGIS or whatever, or a script with parameters. So you can write a workflow and then save it in your Argo deployment, and then yeah, people can come along. We actually do this a lot, so we'll just have parameterized workflows that anybody can come along and run. You can schedule jobs with cron if you're familiar with that. There's lots of like flow control structures within the Argo templating framework. So you've effectively got like a similar kind of level of expression as a programming language. So like loops and conditionals and etc. That kind of flow control. Because Argo's running in your Kubernetes cluster, you've got lots of monitoring. So there's like event emissions, there's metrics, there'll be logging via your Kubernetes setup. You can have exit and success notices, and yeah, we have a bunch of those for different workflows hooked up to Slack, so that we get notifications and logging outputs, etc., posted in specific channels, which is kind of really useful to keeping track of everything. So what does a workflow look like in code? Pretty boring, but I'm going to show you anyway. So if any of you are familiar with Kubernetes, at the top there, we're defining a Kubernetes manifest, basically, which is that API version. And then the kind is a workflow. We set up some parameters. I mean, that's all kind of looking fairly familiar. We set things like names, etc., for a job. Then we define the steps. So with this particular workflow, it's literally going to be one step. But you'll notice on line 22 there, we set a value for the parallelism. So this is how much the job is going to fan out across the number of data sets that we input to it. And then here we're defining the actual container that it's going to run. So on line 45, you'll see that we're grabbing a container image from whatever repo. Bit more setting up of environment variables, etc. We've got retry levels, so that the job will actually, if there's some problem with the network or whatever, the job will retry. For this particular workflow, we're setting some stuff for GDAL that some of you might be familiar with. And then here's the command that we issue. So we have this particular workflow has a Go tool in the container that we're running. And it takes the command of cloud, and then it processes the data sets that we've passed in as parameters. This one is actually this is one of our tiling workflows. So this is basically once we've processed a piece of satellite imagery, and then we want to tile it. So underneath that cloud command, there's basically a whole bunch of XYZ tiling happening, and then that's all getting pushed up to S3 once it's finished. Within Kubernetes, you can also set resources for your different jobs and containers, etc. So here we're doing that. It has a slightly confusing way of expressing the CPU and memory, but again, if you're not familiar with it, go and look it up. I'm just going to go through one more. So this is the definition for this workflow downloads and imports Planet OSM. It's got an exit handler. So if something happens to the job, either it finishes properly, or it hangs, or it for a certain amount of time, or it fails, then that exit handler workflow will get called, and then there'll be notifications and etc. will happen. This one is so it's mounting a persistent volume. If any of you have used Impossum or done any big Planet level OSM imports, you'll know that having like good disk IO is really important. And then this is a DAG definition rather than the last one that was just kind of stepwise. So you'll see like on line 35 that there's a depends, and you can link those together with like the double ampersand convention. So like you might, in an example, I should put one of those up, have a step which depends on many things before it. So you can chain those together and express it that way. Yeah, there's the depends. And then, if any of you are familiar with Impossum, again, we're just writing a shell command directly into the container. This container has got Impossum in it. We set some resources, and then our import starts. There's the exit handler. It's calling another workflow, and this was a bit of a light bulb moment for me with Argo. Basically, so on line 256 there's an action called create, which is getting called, and that's something in Kubernetes which allows you to create a deployment, which will then spin up some pods to do something else. So what happens? This workflow runs all the way through, imports everything into PostGIS, and when it gets to the end, it creates a deployment that's running the replication stream. So we're pulling so once all of the import has happened, it then sets up the system to pull in the replications, which is it's really nice. So what are we using it for at FatMap? OSM Planet imports. All of that gubbins, so all of our satellite imagery processing, there's also feathering in there, and parallelized tile generation for all of our imagery and our terrain. So when new data sets come in, they can all of that is happening across lots of nodes in our cluster. We also use it for database syncs and maintenance operations, but I can't. And then there's also one point that bit of metadata ingestion and cataloging. At Strava, they have one of the projects I've been working on since we started working together is running. They run enormous Spark jobs that call terabytes of Parquet files from S3. And one of the things that we've been doing is moving those onto Argo, because they were finding they were having to babysit them a bit, and there's various things in there. So that's something that's kind of missing off here. Tools that we've put into workflows at FatMap, or certainly I have: Whitebox, Orfeo, lots of Python, GeoPandas, obviously GDAL as well is not on there, and then lots of kind of Go spatial tools. But I can't stress enough how much you can put in there, and so that's kind of why Inception, right? So we need to go deeper. And I was thinking about Ant's talk from last year and using QGIS Modeler and how you can express complex models in there. And I thought maybe maybe you could run QGIS headlessly, and you could just run models in a container, and somebody's already created a container to do just that. So if you were feeling that way inclined, you could take one of Ant's models and put it into some complex workflow and run that on Argo as well. Thank you very much. You're on mute.
Hello. Hello, thank you. That was fascinating. I'm not particularly experienced with Kubernetes myself, and I hear a lot of stuff about how in many situations it's overkill and you're opening yourself up to a massive can of worms by trying to deal with it. I wondered if you could just comment a bit on that in relation to Argo. Is Argo good enough that it's worth going into Kubernetes for it, even if you're not already running things in Kubernetes? Is it worth running? I gather you can run Kubernetes on your local machine for sort of simple things. Is it worth doing that to do Argo stuff there, or should you use some other solution? I just wonder about your opinions about that.
That's an absolutely fantastic question. I was going to have a slide on it, on that exact question. The short answer is no. I think playing around with Kubernetes on a local machine is great for learning, but if you actually want to do something to it, if you want to do something big with it, you're really only going to get the value out of it if you're running it on a cluster. That can be physical. If any of you know John Murray from Liverpool University, he has a physical cluster that he runs Kubernetes now on instead of running Slurm, which was an old HPC tool for running big parallel jobs. So I would say that Kubernetes is a can of worms. But like we're at FatMap and Strava, we're handling huge volumes of users, you know, hundreds of thousands, billions of requests, sometimes like coming in every second to the services. So we have these big clusters that are sat there anyway. And when we have effectively the great thing about Kubernetes is that if you have that, it's scheduling all of that compute across and memory usage, etc., across all of your nodes. So if you've got a bit of downtime, then you can do a bit of data processing. And the other thing is also in the cloud, you have cluster autoscalers, which basically will scale the cluster up or down depending on what's going on. So if you do launch a big job on it, then it will add more nodes automatically, etc., to be able to handle that. So I would say that, like, if your business, and they have about 8 engineers at Strava, and we have 3 engineers who work just full time on Kubernetes. I mean, they do other cloud stuff as well, but a lot of their job is managing the clusters. And then at FatMap, we probably have a bunch of people who are Kubernetes certified administrators and a bunch of power users. So like we have built up quite a lot of knowledge internally of using it. Yeah.
If there are any more questions, I might suggest we actually take them in the break. We've got to switch over to the national keynote. I think, quick one, really quick. Is it quick?
Thanks. So that sounded really interesting, but I didn't understand one bit of what happened for the past 15 minutes. It sounds great, though. Very useful. If I wanted to learn about all that, do you have something to suggest?
Yeah, so the Linux, so Kubernetes, Argo, and a whole galaxy of associated technologies are part of what's called the CNCF, which is the Cloud Native Foundation, which is part of the Linux Foundation, and they have huge amount of resources, both open and paid, that you can go and check out. Crunchy Data, who are the kind of become the sort of de facto maintainers of PostGIS. They also have, if you go on their website and kind of dig around for that, like in their tutorials, they also will link you through to Katacoda, which is a site where you can like basically work on clusters that are sort of spun up for you, so you don't have to do anything. Google obviously were the people who you know, invented Kubernetes, as it were. It came out of a project there called Borg, and they have a lot of resources for learning that stuff. Yeah.
I think we'll wrap up there. Thanks, Ilya. Great talk.
Cheers.
Thanks, everyone. So we've got the next keynote starting shortly, and then there's a break after that, so you can grab a coffee and things at that point.